In our second tutorial, we will recognize and use the pattern for a 30, 60, 90 right triangle. So the second special right triangle that we discovered in geometry is the 30 degree, 60 degree, 90 degree right triangle. And here's a picture of that. Obviously, here's my 90 degree angle. The bigger of the acute angles would therefore be the 60 degree angle, and the smaller one would be the 30 degree angle. So we have our angles. What I like to do is I like to identify the short leg. The short leg will always be the one opposite the smallest angle. And I always like to identify that one. I'm going to put a little squiggly line on there. That's always good for my eyes. Because really this pattern depends on the short leg. And let's label my short leg as X. So if we know what the short leg is, we're simply going to double that, and we have the hypotenuse, 2 times X. I'll just say double. Multiply by 2. If we have the short leg, we double and we have the hypotenuse. If we have the short leg, we multiply it by the square root of 3 and we have the longer leg. And that's the way that I remember this square root of 3. We have 3 different sides in this triangle, 3 different angles in this triangle, and that's why we use the square root of 3 as opposed to the other pattern that has 2 same things, we use square root of 2. This one has 3 different things, we use square root of 3. So we multiply by square root of 3. Another way to sort of visualize this pattern, and I'm going to draw it down here, is if we have a 30, 60, 90 right triangle, that's really, I'll put my little X here, that's really half of an equilateral triangle. So let's imagine that this is an equilateral triangle. If this little leg is X, then this little leg would also be X. And if this whole side of the equilateral triangle is 2X, then that means that all the sides would be 2X. So that's kind of helpful to realize why the short leg times 2 will always be the hypotenuse. Anyway, I like to look at that. Let's put some numbers into this pattern and see if we can figure this one out. Let's bypass these 45, 45, 90s, and let's get to examples 4 and 5. I have my 90 degree, it's a right triangle. One of the angles is 60 degrees, so by some simple math, we know that the other angle must be 30 degrees. So there's A. A is 30 degrees. So now that I have my angles, let's figure out the sides. I like to identify the short leg, which is opposite my 30-degree angle, and here it is. I'll highlight it like this. And I actually already know what my short leg is. It's 5. So I know that I'm going to double it to get my hypotenuse. So that must mean that y is equal to 2 times 5, which is equal to 10. I know you could probably just do that in your head, not show this middle step. And I'm going to multiply by the square root of 3, and I'll have my longer leg, which is x. So x must be 5 times the square root of 3. And that's it. I solved this triangle. It's a whole lot easier when you know a special pattern. You don't have to use Pythagorean theorem, though you could check it. You don't have to use SOHCAHTOA or any of the trig ratios. These are special patterns. We can find our exact values. Let's look at example 5. Okay, and all I know is this is a right triangle. I do know one of the legs is 7, and I know that the hypotenuse is 14. I don't know either of the two angles yet, but I do know that this must be following that pattern because visually, this is the shorter angle, or excuse me, the smallest angle. So this must be the shorter leg, and since this shorter leg is 7, and that is multiplied by 2 to get 14, this must be following our pattern. So this must be a 30 degree, 60 degree, 90 degree right triangle. So I've got 2 of my angles. A is 30 degrees and B is 60 degrees. So I am missing my leg, and this is the longer leg. If I know the shorter leg, I multiply by the square root of 3, and I have the longer leg. So now I know what x is. X is 7 times the square root of 3. Okay? Follows our pattern. And our final example, example 7. Let's see what we have here. 90 degrees, of course. Here's 60 degrees, so this must be my missing 30 degrees. A is 30 degrees. And I know my hypotenuse is 1, but I'm missing this leg and I'm missing this leg. And if I identify my little leg, it's right here. I don't know it. I do know that if I knew what this leg were, I would double it to get the hypotenuse. So it does make sense that I'm going to divide by 2. I'm going to cut it in half. If I know my hypotenuse, to get the little leg, I just cut it in half. So x must be my hypotenuse divided by 2, which is the number 1/2. Okay, that's fine. Remember, you always want to find the little leg first before you try to find the longer leg. So once I know what my little leg is, which I do know, it's 1/2, I'm going to multiply by square root of 3, and I'll have my longer leg y. So y is going to be 1/2 my little leg times the square root of 3. And that is equal to the square root of 3 over 2. Because 1 times the square root of 3 becomes my numerator square root of 3, and the denominator, of course, remains as a 2. I wanted to show you this example, like I said in the end of my previous tutorial, because this triangle will help understand the unit circle. The unit circle has a radius of 1, which is why I made both of these hypotenuses 1. And these values, this square root of 2 over 2, and this 1 over 2, and this square root of 3 over 2, are going to be very helpful to remember your unit circle. So I just wanted to kind of give you a preview of that for next year. Thanks for watching this tutorial on the pattern for 30, 60, 90 triangles, and we'll practice both of these patterns in class. I'll see you then. See ya.